lecture 18 from this channel. Here I am standing near a distribution transformer. You can see a conservator at the top, cylindrical shaped conservator. Silica gel breather is not attached. The tank is supposed to be filled with mineral transformer oil, and the conservator is partially supposed to be filled with transformer oil, so that the conservator oil can compensate for expansion or contraction of oil during summer or winter season. Here you can see the welded portion of the tank, front portion, and here it is back portion. Now what happens, due to crack in the welding balls, or due to seepage from top cover and gasket, the oil begins to leak. What happens when oil begins to leak? You see, due to seepage of oil, these scales have been formed at the transformer base channel. Transformer walls have also been, let me show it to you. See the dirt. See the dirt on the walls of the transformer. This is steel, rather mild steel tank, welded from top, bottom and all sides. Now this oil leakages can damage it, because when oil leakage takes place, either from this welding or from top of gasket, between top cover and gasket. So due to this leakages, our transformer gets a thick or thin coating of, see, this is due to leakage. So what happens then? Inside oil is supposed to be cooled. It is heated due to copper loss and iron loss. These scales prevent the heat to be breathed out from the transformers. See, heating time constant of the transformer is heating time constant Th is equal to G H by S lambda, where G is the weight of transformer, H is specific heat, and S is surface area, and lambda is specific heat dissipation. Now transformer is not a uniform body. Its cores are made of silicon steel, its outer wall are mild steel, it has copper or aluminum winding, then it has oil. So what are the specific heats of different materials? Transformer oils 1670 joules per kg per degree centigrade. Copper 390 joules per kg per degree centigrade, and steel 480 joules per kg per degree centigrade. Now 1 joule is 0.239 calorie. Taking reference from water, the specific heat of transformer oil is 0.39, that of copper is 0.093, and that of steel is 0.114. So taking reference of copper, specific heat of copper is 0.093. So amount of heat required to raise the copper by 1 degree centigrade is 0.039. I'm sorry, 0.093 calorie. So 0.093 calorie is required to raise the temperature of 1 gram copper by 1 degree centigrade. But for oil, transformer oil, it is 0.39. So it is almost, specific heat of oil is almost 4 times that of copper. So with the coating of oil on the walls of transformer, disposal of heat generated inside the tank becomes difficult, and oftenly it gets damaged due to non-disposal of heat. So what maintenance people should do? Maintenance people should continuously watch it and clean the outer surface of the transformer. Thank you. Happy learning. Stay safe.